Hello, friends. In the lecture series of dynamics of atmosphere. So, in today's video, we will be discussing the second kind of force which we were which we were planned to discuss today. In the previous lecture, we discussed the pressure gradient force, and today which were the body force. And in today's video, we will be looking at the surf, which is the body force, which is the gravitational force. So let's get started. So the gravitational force. Okay, so what it is? So Newton law of universal gravitation states that any two elements of mass in universe attract each other with a force proportional to their masses and inversely proportional to the square of their separating distance. Thus, if two mass elements m and small m are separated by a distance r, okay, so suppose we have two mass. Uh, Suppose uh, this is m and this is small m. These are the two masses. And here we have the distance vector from, I'm sorry, this is not right line. It has to be line, but I don't know. Let's see. We can draw the line from here to here. Okay. So, yeah. So what it states, Newton's law of universal gravitation states that any two elements of mass in the universe attract each other with a force proportional to their masses and inversely proportional to the square of the distance separating them. Thus, if two mass elements m and m are separated by distance r, that is, by definition, this is the r vector, with the r directed towards the mass m, which is small m, then the force exerted by mass m, this capital big mass, by mass m on a small mass m due to gravitation would be F g is equal to minus g m m r square vector r by r. Okay, so this will be the proportional. So this is the unit vector in the direction of the from the capital M to small m. So there is the negative sign because the force is will be in this direction for both of them. So before this, from by this it will be attractive. From this to this, it will be attractive. So if you are writing for small m, then it will be of the opposite sign. Where g is, what is g? Where g is the g is universal constant called the gravitational constant. So what is g? G is simply nothing but gravitational constant. Okay. The law of gravitation is expressed in this equation. This is the 1.2, let's say. Actually applies only to the hypothetical masses. The law of gravitational expression actually applies only to hypothetical point masses, since the objects of finite extent r will vary from one part of the object to another part. However, finite bodies may still be applied if r is intercepted as the distance between the center of masses of the bodies. Thus, if the Earth is designated as mass m and m is a mass element of the atmosphere, then the force per unit mass exerted on the atmosphere by the gravitational attraction of the Earth is given by Fg by m is equal to g star is equal to minus capital G m m divided by r square r by r. Okay, this will be gravitational force on mass m of the atmosphere. Okay, so what is this? So if the Earth is designated as mass m and m is a mass element of the atmosphere, then the force per unit mass exerted on the atmosphere by the gravitational attraction of the Earth is Fg divided by m is equal to g star is equal to minus gmm divided by r into magnitude of r. So minus gmm by r square magnitude of r. Okay, so in dynamical meteorology, it is customary to use the height above mean sea level as vertical coordinate if the mean radius of the Earth is designated by a. Okay, so what happens that over the Earth's surface uh, we have mountain, we have everything. So the Earth is not really perfect, smooth sphere, but it has heterogeneities. So the surface. So what we do? So in dynamical meteorology, it is customary to use the height above sea level as vertical coordinate. If the mean radius of the Earth is designated by a, let's say we have the radius of a, and the distance above mean sea level is, let's see, this is z, mean sea level, then neglecting the small departure of the sphere of the Earth from sphericity, the r would be equal to a plus z is the distance. Therefore, the 1.3 can be written as g star is equal to uh, g star naught divided by 1 plus z by a square, where uh, where where g naught star is equal to minus capital Gm a square r by r is the gravitational force at mean sea level. Okay, so this is the gravitational force at mean sea level, and this is scaled by some constant or some variable which depends upon the distance from the Earth's surface. Okay, so for meteorological applications, okay, for in general meteorology, what happens that z becomes very less than a. So the negligible error. So with the negligible error, what we have g star is equal to z naught star, okay? And simply treat the gravitational force as constant. So we can consider it as constant, almost constant. Okay. So this is all about the gravitational force. In the next video, we'll be looking at the viscous force and how we can learn more about it and how we can derive the various equations for it. And that would be of great interest. Thank you very much for watching. I will see you in the next video. Till then, bye bye and take care.